came first, the chicken or the egg? Did the universe have a beginning, and if so, what happened before then? Where did the universe come from, and where is it going?
Luck.
How real is time? Will it ever come to an end? Where does the difference between the past and the future come from? Why do we remember the past, but not the future? I was born exactly 300 years after the death of Galileo. I estimate that about 200,000 other babies were also born that day. I don't know whether any of them was later interested in astronomy. Before the 20th century, it was thought that the universe had existed forever, or had been created at some time in the past, more or less as we observe it today. People found comfort in the thought that even though they may grow old and die, the universe was eternal and unchanging. When I was in high school, I learned that light from distant galaxies was shifted to the red. This meant that they were moving away from us, and that the universe was expanding. But I didn't believe it. A static universe seemed much more natural. It could have existed, and could continue to exist, forever. The expansion of the universe suggested the possibility that the universe had a beginning at some time in the past. The point at which the universe may have started out became known as the Big Bang. In an unchanging universe, one can imagine that God created the universe at literally any time in the past. On the other hand, if the universe is expanding, there may be physical reasons why there had to be a beginning. An expanding universe does not preclude a creator, but it does place limits on when he might have carried out his job. I once calculated that I did about 1,000 hours work in the 3 years I was at Oxford, an average of an hour a day. I'm not proud of this lack of work. I'm just describing my attitude at the time, an attitude that nothing was worth making an effort for. Because of my lack of work, I had planned to get through the final exam by doing problems in theoretical physics and avoiding any questions that required factual knowledge. I didn't do very well. I was on the borderline between a first and second class degree, and I had to be interviewed to determine which I should get. They asked me about my future plans. I replied, if they gave me a first, I would go to Cambridge. If I only got a second, I would stay in Oxford. They gave me a first. I felt that there were two areas of theoretical physics I might study at Cambridge. One was cosmology, the study of the very large. The other was elementary particles, the study of the very small. However, I thought that elementary particles were less attractive, because there was no proper theory. All they could do was arrange the particles in families, like in botany. In cosmology, on the other hand, there was a well-defined theory, Einstein's general theory of relativity. Shortly after my 21st birthday, I went into hospital for tests. They took a muscle sample from my arm, stuck electrodes into me, and injected some radio-opaque fluid into my spine, and watched it going up and down with X-rays as they tilted the bed. I was diagnosed as having ALS, amyotrophic lateral sclerosis, or motor neuron disease, as it is also known. The doctors could offer no cure, and gave me 2.5 years to live. My dreams at that time were rather disturbed. Before my condition had been diagnosed, I had been very bored with life. There had not seemed to be anything worth doing. But shortly after I came out of hospital, I dreamt that I was going to be executed. I suddenly realized that there were a lot of worthwhile things I could do if I were reprieved. At first, there did not seem much point in working at my research, because I didn't expect to live long enough to finish my PhD. However, as time went by, the disease seemed to slow down. I began to understand general relativity and make progress with my work. But what really made a difference was, I got engaged to a girl called Jane Wilde. This gave me something to live for, but it also meant that I had to get a job if we were to get married. I wanted to understand how the universe began. Einstein's theory of general relativity showed that the universe was expanding. But there was no answer to the crucial question, must there have been a Big Bang, a beginning to time? Then, in my 3rd year at Cambridge, Roger Penrose made his discovery about the death of stars.
Recuerdo que hablaba con mi amigo Ivo Robinson. Era una conversación muy animada y entonces tuvimos que cruzar una calle. Mientras cruzábamos, claro, dejamos de hablar. Y cuando llegamos al otro lado, evidentemente algo se me ocurrió mientras cruzaba, pero al reanudar la conversación se borró del todo de mi mente. Y ya después, cuando mi amigo se había ido, tuve una rara sensación de euforia. Me sentía fenomenal. Y como no me imaginaba por qué me sentía así, repasé el día pensando qué podría causar un sentimiento de ese tipo. Y poco a poco desenterré la idea que se me ocurrió mientras cruzaba.
Penrose anunció su conclusión de que cuando las estrellas entran en fase de destrucción, se hacen puntuales siempre que se cumplan unas condiciones que todos considerarían razonables. Y recuerdo que Stephen Hawking, que llevaba casi 3 años como estudiante investigador, dijo: «¿Qué resultados tan interesantes? ¿Será posible adaptarlos a la comprensión del origen del universo?». Y lo que él pensaba era que si mentalmente se invertía el sentido del tiempo, se podía considerar el universo en expansión como un sistema degenerativo, como una gigantesca estrella en fase de destrucción.
Roger Penrose proved that a dying star, collapsing under its own gravity, eventually shrinks to a singularity, a point of infinite density and zero size. I realized that if I reversed the direction of time so that the collapse became an expansion, I could prove that the universe had a beginning. But my proof, based on Einstein's theory of general relativity, also showed that we cannot understand how the universe began, because it showed that all scientific theories, including general relativity itself, break down at the beginning of the universe.
Tuvimos una reunión en el Instituto de Física Espacial de Nueva York y yo dije: antes de llegar a una conclusión final, hay que tener en consideración un nuevo objeto, un objeto totalmente contraído por gravitación. Después de usar la frase objeto totalmente contraído por gravitación 10 veces, queda claro que hay que darle otro nombre. Así que se me ocurrió la palabra agujero negro.
Tonight, my friends, we stand on the brink of a feat unparalleled in space exploration. If the data on my returning probe ship matches my computerized calculations, I will travel where no man has dared to go. Into the black hole? In, through, and beyond.
Why, that's crazy. Ha! Impossible.
As a massive star contracts, its gravity becomes so strong that light can no longer escape. The region from which nothing can escape is called a black hole, and its boundary is called the event horizon. One might say of the event horizon what Dante said of the entrance to hell. Abandon all hope, ye who enter here.
Believe me, I've been waiting a long time for someone like you to record this moment.
Thank you, Doctor.
Then I'm ready. Ready to embark on man's greatest journey.
Certainly his riskiest.
The risk is incidental compared to the possibility to possess the great truth of the unknown. There, long-cherished laws of nature simply do not apply. They vanish.
And life?
Life? Life forever.
If you were watching an astronaut, foolhardy enough to jump into a black hole, at some time on his watch, say 12 o'clock, he would cross the event horizon and enter the black hole. But no matter how long you waited, you would never see the astronaut's watch reach 12 o'clock. Instead, each second on the watch would appear to take longer and longer, until the last second before midnight would take forever. Thus, by jumping into a black hole, one could ensure that one's image lasted forever. But the picture would fade very rapidly, and grow so dim, that no one could see it.
Si alguien entra en un agujero negro, visto desde fuera, parece que el tiempo se alarga y esa persona se mueve o cree que se mueve y quizá habla en su nave espacial a velocidad normal, pero se ralentiza y se detiene en una posición determinada para un determinado observador exterior. Desde fuera no puede verse qué pasa después.
The astronaut wouldn't notice anything special when his watch reached midnight, and he crossed the event horizon into the black hole. Until, of course, he approached the singularity and was crushed into spaghetti. In the long history of the universe, many stars must have burned up their nuclear fuel and collapsed in on themselves. The number of black holes may be greater than the number of visible stars, which totals about 100,000 million in our galaxy alone. We also have evidence that there is a very large black hole at the center of our own galaxy.
Mis amigos me preguntan, si un agujero negro es negro, ¿cómo se puede ver? Yo les digo, ¿has estado alguna vez en un baile? ¿No has visto a los jóvenes vestidos de negro, de smoking, y a las chicas con sus vestidos blancos dando vueltas, abrazados por parejas y a media luz? Solo se ve a las chicas. Pues la chica es la estrella común y el chico el agujero negro. No se ve el agujero negro como no se ve al chico, pero la chica dando vueltas indica claramente que debe haber algo ahí que la mantiene en órbita.
One evening, shortly after the birth of my daughter, Lucy, I started to think about black holes as I was getting into bed. My disability makes this rather a slow process, so I had plenty of time. Suddenly, I realized that the area of the event horizon must always increase with time. The increase in the area of the event horizon was very reminiscent of a quantity called entropy, which measures the degree of disorder of a system. It is a matter of common experience that disorder tends to increase with time if things are left to themselves.
Jacob Bekenstein came into
Jacob.
My discoveries led Jacob Bekenstein to suggest that the area of the event horizon actually was the entropy of a black hole. But there was one fatal flaw in Bekenstein's idea. If black holes have an entropy, they ought to have a temperature. And if they have a temperature, they ought to give off radiation. But how could they give off radiation if nothing can escape from a black hole? As it turned out, Bekenstein was basically correct, though in a manner far more surprising than he, or anyone else, had expected. My work up to 1973 was in general relativity, and was summarized in a book I wrote with George Ellis, called The Large-Scale Structure of Space-Time. Even then, it was difficult for me to write things down. so I tended to think in pictures and diagrams that I could visualize in my head. General relativity is what is called a classical theory. It predicts a single definite path for each particle. But according to quantum mechanics, there is an element of chance or uncertainty. A particle does not have just a single path through space and time. Instead, there is an uncertainty principle, according to which both the exact position and velocity of a particle can never be known. I began investigating the effect quantum mechanics might have on particles near a black hole. I found that particles could escape from a black hole, that black holes are not completely black. At first I didn't believe it. But when I redid the calculations, I couldn't get the effect to go away.
I met Martin Reed.
I was still unsure of my discovery, so I only told a few colleagues. But word soon spread. Roger Penrose phoned up on my birthday. He was very excited, and went on so long that my birthday dinner got quite cold. It was a great pity, because it was goose, which I'm very fond of.
To me, it's a myth.
I finally convinced myself that black holes radiate when I found a mechanism through which this could happen. According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so, black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion. Quantum mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole. Einstein never accepted quantum mechanics because of its element of chance and uncertainty. He said, God does not play dice. It seems that Einstein was doubly wrong. The quantum effects of black holes suggest that not only does God play dice, he sometimes throws them where they cannot be seen.
He says
Black hole radiation has shown us that gravitational collapse is not as final as we once thought. If an astronaut falls into a black hole, he will be returned to the rest of the universe in the form of radiation. Thus, in a sense, the astronaut will be recycled. However, it would be a poor sort of immortality, because any personal concept of time would come to an end as he is torn apart inside the black hole. all that would survive would be his mass, or energy. In 1979, I was elected Location Professor of Mathematics. This is the same chair once held by Isaac Newton. They have a big book, which every university teaching officer is supposed to sign. After I had been Location Professor for about a year, they realized I had never signed. So they brought the book to my office, and I signed with some difficulty. That was the last time I signed my name. My interest in the origin and fate of the universe was reawakened when I attended a conference on cosmology in the Vatican. Afterwards, we were granted an audience with the Pope. He told us that it was all right to study the evolution of the universe after the Big Bang, but we should not inquire into the Big Bang itself, because that was the moment of creation, and therefore the work of God. I was glad that he did not know the subject of the talk I had just given. The possibility that the universe had no beginning, no moment of creation.
Había teorías a principios de los 70, las primeras sobre la creación, en las que se partía de un espacio externo fijo en el tiempo, que siempre habría estado vacío, y de repente, sin saber por qué, el universo forma un núcleo en un punto dado y estalla. El problema es que cuando el espacio y el tiempo aparecen en la teoría clásica, ese mismo punto es un punto singular en matemáticas. Las matemáticas fallan y por tanto no podemos usar eso como teoría de la creación.
If one goes back in time, one comes to the Big Bang singularity, where the laws of physics break down. But there's another direction of time that one can go in, which avoids the singularity. This is called the imaginary direction of time. In imaginary time, there need not be any singularities which form a beginning or end to time.
En tiempo imaginario tenemos la curiosa posibilidad de tener un ahora, digamos, sin tener necesariamente una cadena de momentos pasados. Si partimos de donde estamos y retrocedemos en el tiempo, todo irá bien durante un largo periodo. Pero conforme retrocedemos, nos acercamos a lo que sería el punto de origen en el tiempo real convencional. Descubrimos que la naturaleza del tiempo cambia, que el componente imaginario se hace cada vez más importante. Y al final, lo que sería el punto singular en la teoría clásica desaparece y tenemos la preciosa imagen de esa especie de cuencos con que se describe la creación del universo. Ahora estamos aquí, una especie de cuenco del pasado donde no hay punto inicial, sino un perfil redondeado.
So long as the universe had a beginning, we could suppose it had a creator. But if the universe is completely self-contained, having no boundary or edge, it would neither be created nor destroyed. It would simply be. What place, then, for a creator?
Podemos decir que el universo es porque es una estructura matemática independiente. No hay pasado porque, a diferencia de la creación, punto inicial, aquí no hay nada que crear. Decir que está creado de la nada es inapropiado, una mala utilización de la palabra nada. No es que hubiera un espacio vacío en el que apareció el universo, que llamaríamos la nada. Es que no había nada en absoluto. La utilización del pretérito de un verbo es inadecuado en estas teorías. Por desgracia, los tiempos de los verbos se hicieron cuando se creía en el tiempo real, y aún no tenemos una forma lingüística para los verbos en tiempo imaginario.
La palabra tiempo no ha venido del cielo como un regalo de las alturas. La idea del tiempo es un concepto inventado por el hombre. Y si conlleva ciertas confusiones, ¿de quién es la culpa? Es nuestra.
Where does the difference between the past and the future come from? The laws of science do not distinguish between the past and the future. Yet, there is a big difference between the past and future in ordinary life. You may see a cup of tea fall off a table and break into pieces on the floor, but you will never see the cup gather itself back together and jump back on the table. The increase of disorder, or entropy, is what distinguishes the past from the future, giving a direction to time. Before I caught pneumonia, my speech had been getting more slurred, so that only a few people who knew me well could understand me. But at least I could communicate. I wrote scientific papers by dictating to a secretary, and I gave seminars through an interpreter. And then, a tracheostomy operation removed my ability to speak altogether.
Después de mucho tiempo, o al menos eso parecía, se presentaron con ese maravilloso aparato. No lo tenían en el hospital Cambridge. Lo habían traído de Londres. Era alta tecnología, poderse comunicar con alguien sin voz. Es como un trozo de plástico de este tamaño y las letras del alfabeto colocadas así con un agujero en el medio. Lo pones entre tú y la otra persona y él mira una letra. Tú puedes ver qué letra está mirando casi siempre, aunque a veces no estás seguro. Así que el paciente deletreaba lo que quería. Él miraba una letra, por ejemplo, la A. Tú preguntabas, ¿la A? Eso es. Parecía un acertijo.
Steven wasn't.
A computer expert in California heard of my plight and sent me a computer program called Equalizer. This allowed me to select words from a series of menus on a screen by pressing a switch in my hand. These words could then be sent to a speech synthesizer attached to my wheelchair. Much to my surprise, I found I was able to communicate much better than before. I began to wonder what would happen when the universe stopped expanding and began to contract. Would we see broken cups gather themselves together off the floor and jump back onto the table? Would we be able to remember tomorrow's prices and make a fortune off the stock market? It seemed to me the universe had to return to a smooth and ordered state when it recollapsed. If this were so, time would go backwards when the universe began to collapse. People in the contracting phase would live their lives backward. They would die before they were born and get younger as the universe got small again. Eventually, they would return to the womb.
He gave me my first problem to do.
Me planteó mi primer problema. Me pidió que resolviese un problema matemático y normalmente al plantear un problema sabe cuál va a ser la solución. Me puse a ello y tardé unos meses en comprender de qué iba. Volví y le dije, esta es mi respuesta. Él me dijo, no, no es lo que esperaba. Le dije, es lo que me sale. Fui a la pizarra y se lo expliqué. Me dijo, ¿has pensado en ese caso particular? Le dije, ah, pues no. Hice cálculos sobre lo que él me decía. Volví unas semanas después y le dije, Steven, no lo consigo. Sigo obteniendo la misma respuesta que antes. Él me dijo, no, algo falla. ¿Has pensado en esto? Dije, oh no, he olvidado ese caso particular. Así que volví al tablero a rehacer los cálculos y de nuevo la misma respuesta. Así que fui a verle. Esto ya duraba 2 o 3 meses. Por fin me dijo, quizá una de tus aproximaciones no es válida. Un colega y yo decidimos utilizar un ordenador. Se tarda mucho tiempo en escribir los programas y en asegurarse de que son correctos. Obtuvimos la respuesta y seguía siendo lo que yo había dicho y no lo que decía Steven. Fuimos a verle y le dijimos, mira, lo mismo.
I had made a mistake. I had been using too simple a model of the universe. Time will not reverse direction when the universe begins to contract. People will continue to get older, so it is no good waiting until the universe recollapses to return to our youth. Einstein once asked the question, how much choice did God have in constructing the universe? If my proposal that the universe has no boundary is correct, he had no freedom at all to choose how the universe began. He would only have had the freedom to choose the laws the universe obeyed. This, however, may not have been all that much of a choice. There may well be only one unified theory that allows for the existence of structures as complicated as human beings, who can investigate the laws of the universe and ask about the nature of God. Even if there is only one possible unified theory, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? Why does the universe go to all the bother of existing? Is the unified theory so compelling that it brings about its own existence? Or does it need a creator? And, if so, who created him? In real time, the time in which we live, the universe has 2 possible destinies. It may continue to expand forever, or it may recollapse and come to an end at the Big Crunch. It would be rather like the Big Bang, but in reverse. I now believe that the universe will come to an end at the Big Crunch. I do, however, have certain advantages over many other prophets of doom. Whatever happens 10 billion years from now, I don't expect to be around to be proved wrong.
Of all the pictures that I know,
de todos los modelos que conozco,
of any cosmology,
la cosmología más simple
in which the universe
es aquella en la que el universo es cerrado, tiene una vida limitada
with the same
y
kind
se
of
destruye
collapse
por el
as
mismo
a black hole
procedimiento
does.
que un agujero negro.
If it should turn out
Si resulta que en realidad el universo tiene una vida limitada, ¿en qué se diferencia de la vida de cada uno de nosotros?
On the evening of Tuesday, March 5th, at about 10:45, I was returning to my flat in Pinehurst. It was dark and raining. I came up to Grange Road and saw headlights approaching, but judged that they were far enough away that I could cross safely. The vehicle must have been traveling very fast, for when I got just past the middle of the road, my nurse screamed, "Look out." I heard tires skidding, and my wheelchair was struck a tremendous blow in the back. I ended up in the road, with my legs over the remains of the wheelchair. The accident destroyed my wheelchair, and damaged my computer system, with which I communicate. I required 13 stitches in my head, but I was able to go back to work several days later. If we do discover a complete theory of the universe, it should in time be understandable in broad principle by everyone, not just a few scientists. Then we shall all, philosophers, scientists, and just ordinary people, be able to take part in the discussion of why it is that we and the universe exist. If we find the answer to that, it would be the ultimate triumph of human reason. For then we would know the mind of God.